Unit conversions. We're going to use unit cancellation to convert between units. Before we get started, let's take a look at just a couple little things from math. We know that 2 divided by 2 is 1. So we could say that the 2's have canceled. We also know that 2 times a 1 over 2 is the same as writing 2 over 2. So again, we could say that the 2's have canceled, leaving us a 1. The same thing works with variables. So an x over x is still 1. The x's have canceled. And x times 1 over x is still 1. The x's have canceled. So the same thing works with units. A centimeter times 1 over a centimeter, the centimeters have canceled. We're left with 1. So if something has a unit in both the numerator and the denominator position of a fraction that's being multiplied, we can say that they cancel. So we're going to use that property. If something is in a numerator, to cancel it, we need to have that same unit in a denominator. Let's take a look at this example. Converting 0.125 years into seconds. So what I'm going to do is I'm going to start with my 0.125 years. Now I'm going to set it up that I'm going to multiply by some sort of fraction. And like we just said, I need to get rid of the unit years because in the end, I want to end up with something in seconds. There's no years in that unit. So years need to go on the bottom. Well, what do we know is smaller than a year? We could convert years into days. So we can say that 365 days is equal to 1 year. Or that 1 year is equal to 365 days. Obviously, these are the same thing. They just look slightly different in the way that I've written them. I can convert these into a fraction, okay, or a ratio, if you will, here. So I can say that 1 year, there's 1 year per 365 days. I can also say that there are 365 days per 1 year. So notice that I flipped the way that I wrote my equals, but I can also flip the ratio in the way that I've written them. Now remember, back to our little example here, I have years in the bottom of my ratio. So of the two ratios here, which one do I want to choose? I want to choose this one because years are in the denominator and we're converting to a smaller unit of days. So I'm going to put days here, that's my unit, and then I always fill in my numbers after. There are 365 days in 1 year. The units of years cancel, and we can look at days. Days isn't what I want. Again, we're looking for seconds. So I'm going to multiply by another ratio. To cancel the unit of days, I'm going to put days in the bottom. From there, I need to choose something smaller than a day. A smaller increment than 1 day would probably be hours. Now you can write this all out again, but we know that in 1 day, there are 24 hours. So I'm going to fill in those numbers corresponding with their unit. Days were in the bottom. So 1 day is equal to 24 hours. Again, I could have written out all of this information for days to hours, but you're going to get more comfortable with just working it out in your head, I'm sure. Okay, so from this point, days cancel, and I'm left with hours. That's the unit that hasn't been crossed out yet. It's the only one left. So if I did my calculation at this point, if I multiplied 0.125 by 365 by 24 and divided by 1, I would get the number of hours in 0.125 years. So because we don't have our desired unit, we need to keep going. Now, I need to cancel hours, and I'm going to break it down into a smaller increment. A smaller increment than hours would be minutes. I know that there are 60 minutes in 1 hour. 60 minutes in 1 hour. Hours cancel. And I'm left with the unit of minute. So we're almost there. We have one more to do. We need to cancel minutes. A smaller increment than minutes is seconds. There are 60 seconds in 1 minute. Our unit of minutes cancel. And the only unit we're left with is seconds, which is what we wanted in the end. All right, now how do I multiply this in my calculator? A lot of students will go and they'll say 0.125 times bracket 365 divided by 1 bracket times 24 divided by 1 bracket times 60 divided by 1 bracket times 60 divided by 1 bracket and press enter. Now that's a lot of work. So because we're using BEDMAS here, and the only two operations we have are multiplication and division, it actually doesn't matter. We can move left to right. So I'm going to multiply the top by the bottom, and then divide by the bottom. So I'm going to multiply all the way across the top. I'm going to multiply all these numbers together and press enter in my calculator. So I ended up with 3, 9, 4, 2, 1, 2, 3 zeros. And the unit up top is seconds. That's the only one that hasn't been crossed out. And technically I need to multiply all the way across the bottom. Now in this case, all of the numbers in the bottom are a 1. So 1 times 1 times 1 times 1 is just 1. And there's actually no unit on that 1 because all of the units in our denominators have been canceled out. So this is an easy finish to the question because we actually don't need to divide any two numbers here because of this one. So 3,942 divided by 1, or sorry, 3,942,000 divided by 1 is just 3,942,000 seconds. So that would be my final answer, but there's one more consideration we have to make. We need to consider significant digits. So in my question, the measured quantity was 0.125 years. 0.125 years is 3 significant figures. Again, the leading zero does not count. So I need to report this answer to 3 significant digits. These are the most important 3 numbers. Remember, my decimal is here. There's no way that I can represent 3,940,000 without using scientific notation for 3 significant digits. So we have 3.94 times 10 to the 1, 2, 3, 4, 5, 6 seconds is my final answer. Now, one thing to note, we could have in another example, perhaps, a number, let's say 432, and it would have units, and I have to multiply by a few fractions like this. So again, I multiply all the way across the top. So that would be 432 divided by everything multiplied across the bottom. So 4 times 6 is 24, times 3 is 72. To finish up my question, I simply need to finish that division statement. So 432 divided by 72 is 6. That would be my final answer. So multiply all the way across the top and all the way across the bottom, and then finish by completing your division statement here. There's some practice in our booklet, questions 20 through 23. And 23 really brings it into the idea of chemistry. Now, of course, we're going to use unit conversions to go from grams to kilograms or milligrams to kilograms and liters and all of that. But where we really use this is in our final unit, and we are looking at stoichiometry. So I put a little bit of a challenge question there to start getting you to think in units of chemistry.